Hi and welcome to this video on bond energy calculations. There is more content, quizzes and past papers on the website, which is www.elevise.co.uk. This video builds on the content that was discussed in the endothermic and exothermic reaction video, so have a look at that video first before working through this one. In that video we looked at reaction profiles. A reaction profile tells us how the energy changes during a reaction. From a reaction profile we can see the amount of energy that is needed to kickstart the reaction, and this is known as the activation energy, and we can also see the overall energy change. The overall energy change is the difference between the energy in the product and the energy in the reactants. A positive value for the overall energy change means that the reaction is endothermic, and a negative value means that the reaction is exothermic. We are able to use bond calculations to work out if a reaction is exothermic or endothermic. When a reaction takes place, the bonds in the reactants are broken and new bonds are created to form the products. The process of bonds breaking is endothermic. This means that energy is needed in order to break the bonds of the reactants, and this is known as the activation energy. The creation of new bonds in the products leads to energy being released. Bond creation is exothermic. We can work out the overall energy change by using the following equation. Overall energy change equals energy required to break the bonds minus energy released from bonds formation. In order for bonds to be broken, energy needs to be taken in, and this is why it appears as a positive value. When bonds are created, energy is released, and this is why it appears as a negative value. The value for overall energy change informs us as to whether the reaction is endothermic or exothermic. A positive value for overall energy change means that there is more energy required to break the bonds in the reactant than the energy that is released when the bonds in the products are created. This means that the reaction is an endothermic reaction, and the energy of the product is going to be greater than the energy that is contained in the reactants. A negative value for overall energy change means that there is more energy given out by the formation of bonds in the products than the energy that is required to break the bonds in the reactant. This means that the reaction will be exothermic, as the products have a lower amount of energy compared to the reactants. So let's have an example. Hydrogen and chlorine react to produce hydrogen-chlorine gas. The balance symbol equation is H2 plus Cl2. These react together to produce 2HCl. Below the balance symbol equation, I have put a bond diagram. You can see that there is one molecule of hydrogen, one molecule of chlorine, and two molecules of hydrogen-chlorine gas. So what we want to know is this reaction exothermic or endothermic? The first step is to calculate the energy that is required to break the bonds. The reaction is the breaking of H2 and Cl2. To work out the amount of energy that is required, we do the number of that type of bond times the energy needed to break that bond. There is one HH bond being broken, and the energy required to break 1 mole of HH bonds is 436 kilojoules. There is also one Cl-Cl bond being broken, and the amount of energy required to break 1 mole of Cl-Cl bonds is 243 kilojoules. Therefore, the energy required to break the bonds is 1 times 436 plus 1 times 243, and this is 679 kilojoules per mole. The next step is to work out the amount of energy that is released by the new bonds. The products of this reaction are HCl, and there are 2 of them. In each of the 2 HCl's, there is one HCl bond. Therefore, the energy released in the production of the new bond is 2, which is the number of HCl bonds that there are, times 432, which is the energy that is released in the production of one HCl bond. This tells us that there is 864 kilojoules of energy released per mole. The final step is to work out the overall energy change. The overall energy change is the energy required to break the bonds minus the energy released by bonds being created. We therefore do 679 minus 864. This gives us a value of minus 185 kilojoules per mole. As this value is negative, it means that more energy is being released by the formation of the bonds than the amount of energy that is required to break them. This tells us that the reaction is an exothermic reaction. So let's have another example. Is the decomposition of hydrogen bromine an endothermic or exothermic reaction? The symbol equation for the decomposition of hydrogen bromine is as followed. Also, here is the energy tables per mole of the substances. Pause the video now and give this question a go. The first step to answering this question is to work out how much energy is needed to break the bonds. The bonds that are being broken are the HBr bonds. There are two molecules of hydrogen bromine, and within each molecule there is one HBr bond. Therefore, there is two HBr bonds being broken on the left-hand side. We therefore do 2 times the energy that is needed to break one HBr bond, which is 366. When we times 2 by 366, we see that the energy needed to break the bonds is 732 kilojoules per mole. The next step is to work out the amount of energy that is given out by the creation of new bonds. There is one hydrogen-hydrogen bond and one bromine-bromine bond. The energy required to break 1 mole of hydrogen-hydrogen bonds is 436 joules, and the energy required to break 1 mole of bromine-bromine bonds is 193. Therefore, we do 1 times 436 plus 1 times 193. This gives us a value of 629 kilojoules per mole. The final step is to work out the overall energy change. The overall energy change is the energy required to break bonds minus the energy released by bonds formation. We therefore do 732 minus 629, and this equals 103 kilojoules per mole. This is a positive value, and therefore this reaction takes in more energy than is released. This means that the reaction is endothermic. Bond calculations are quite tricky, but the more practice you do, the easier they become. There is more questions on the website, which is www.elevise.co.uk, so give them a go.